and welcome to the reverse engineering and precision manufacturing of a Fentex 3.5-inch toolless HDD tray. Here are the group members. Each group member will present their respective part, and I'm Zane Story, the director of this presentation. Here is Rachel with the literature review.
Harlem's 2022 report explored the potential of 3D scanning in industry and its growing interest, predicting that the market will increase at 7.5% in the next 5 years. There are limitations to 3D scanning. Tools such as developer spray has been employed to generate an accurate mesh. Furthermore, 3D scanning was found to be not the most optimal process for simpler components where manual measurements is faster. However, 3D scanning still has a space in industry where it remains to be a prominent emerging technology due to its niche applications, that being for thin-shelled or rubber parts.
Here is Luke with the methodology and engineering drawings.
The RevoPoint POP2 3D scanner was used to scan the part. This scanner is a dual-camera infrared structured light scanner with 0.05mm precision and up to 0.1mm accuracy in a single frame. To make the black acrylic hard drive tray visible to the scanner, it was painted white prior to 3D scanning. To capture the scans, the hard drive tray was placed on the turntable, and the RevoScan software was used to capture a 360-degree view of each side of the part. Handheld scans were taken of the details. To process the scans, each scan was imported into Revo Studio, and the overlap detection function was used to remove duplicate points. The scans of the top and bottom of the part taken on the turntable were merged, then each detail scan was merged into the final scan. The final scan was imported into Blender, and the decimate modifier was used to reduce the number of vertices. The scan was then traced in Blender using hard surface modeling. The model was exported as STL and imported into SolidWorks so engineering drawings could be created.
Four manufacturing processes were considered: 3D printing, injection molding, CNC machining, and sheet metal bending. However, 3D printing was cut out of this process as the production times are too long, and investment costs for increasing it by purchasing more 3D printers was deemed infeasible. Here's Dan with the injection molding.
One of the most common ways to produce a part is to use a process called injection molding, a process where molten plastic is injected to the mold, filling up the cavity which have the geometry of the part. To begin the process, we need to create a mold. We can create one either by 3D printing, CNC machining, or electrical discharge machining, which is also known as EDM. The method we use will depend on our volume of production. Low volume of production, we use 3D printing, while high uses EDM. Other than the mold, the machine used for injection molding have two other components: the clamping unit and the injection unit. The process of injection molding involves closing the two halves together, melting the plastic and injecting it into the mold, waiting for it to cool down, then remove it out of the mold when the part hardens up. The advantages of injection molding includes quick and cheap manufacturing of part with great tolerances and finishes, while still providing good enough strength and durability. The disadvantages of using injection molding include the high initial cost of the mold as well as the expensive tooling cost.
CNC machining is a computerized manufacturing process in which pre-programmed software and code controls the movement of cutting equipment, produces a great tolerance and finish, has great strength due to the metals it can work with, is a lengthy manufacturing process though, and can be very expensive depending on the complexity of the geometry. There's two main ways we could use CNC machining. The first is to create the mold block for the injection process. The second is also to go over and details and create a better surface and go over holes and cuts to create better tolerances than what the injection molding process could do. Is 10 with sheet metal bending.
The part can also be manufactured using sheet metal as it only have flat surfaces. This method mainly consists of bending the sheet metal into the desired geometry. Before bending, we need to cut the sheet metal into shape. We can either use the laser cutter, plasma cutter, CNC router, water jet cutter, or abrasive disc. All these tools are viable when it comes to cutting the shaft of the sheet metal, but CNC router and water jet cutter will give a better finish without cleaning out. Some positive to using the sheet metal to make the hard drive tray include relatively quick manufacturing time while giving the final product great strength, durability, and finish with decent tolerance. Even so, the part can be costly to produce due to the labor, equipment, and cost.
This left us with two different proposed reproductions. The first was through injection molding by creating a mold with metal CNC machining, injecting the mold with molten plastics. This would give high production volume and cheap material costs. However, on the other hand, we could also use sheet metal, laser cutting, and bending. From single sheet metal, laser cut, and bend the sheet metal. It was a simple process and will end in a high strength design.
We'll be going to conclude this presentation. So basically we have to do the analyze and reverse engineering manufacturing for HDD tray in this project. For the CAD model, the RevoPoint POP2 3D scanner is used, which can scan the image with 0.05mm precision. Software RevoScan, RevoStudio Blender, and SolidWorks for engineering drawing and proper dimensioning. The reverse engineering is a technique to create an accurate model. So for reverse engineering of the hard drive tray, a CAD and an engineering drawing is used to recreate the specification and dimensions of the tray. A mod is to be modeled by using the cavity tool in SolidWorks. We have selected injection molding as our manufacturing process as